Hello? Okay. usually make once I was 7 years old. Dun, dun. Once I was 7 years old. Um, my bad, my bad, my bad. Okay, so the goal of today's stream. So yesterday in yesterday's stream we tried to attempt this question. Well, we didn't try to attempt this question. We just give ourselves this question and they used the AI to completely solve it. But I'm not happy with that, so I'm going to restart this question again and just try and solve it. So basically, this is trying to like simulate the game of life. It was working fine yesterday. I don't know what's going on now. But basically, it's like you have like some white pixels and black pixels, and they are dancing on your screen. In fact, white and green pixels. Let's see. Oh yeah, while using this code with the wait. I don't know. I don't know what's wrong with it, but like I could never comprehend what it was doing to begin with. So the whole point of today now is that I'm going to attempt the question again and try and make sense of it. Try and it. Maybe it's the noise. I don't know what's going on. One is that yesterday, um, this worked on stream. Um, Gemini figured it out, but now it's not working. So, like I said, but it's a really complex question, challenge that I am not yet ready to solve, but I think it will be fun trying to solve it tonight. Like, actually solve it. So, what I'm going to do is I'm going to get the question again. I'm going to give it to Gemini. I'm going to ask it to like guide me through solving it. I'm going to. I'm not going to use this. I really don't know. I've not read it, and I'm not going to read it. I'm going to just reattempt to solve it again. So what I'm going to do is going to come to the root folder here. I'm going to delete them. I'm just going to delete this. Take it, man. I'm going to come here. I'm just going to select all. I'm going to remove it. So we have a blank canvas to work with. I'm just going to give this a shader type of canvas item. Then I'm going to just say think this line should have a semicolon to end it. I'm just going to define the fragments. It's a void function, a void fragments, and so just this, and I'm just going to set color to be equal to vec or um maybe a red, zero green, blue, zero. Or let's just give this UV dot x. Okay. Oh yeah, I'm also in this difference of semicolon. All right. So I'm just going to come here. We knew that they use sub viewport for some specific reason for sub viewport container. I'm going to create a sub viewport container. I'm going to I think I'm going to make this. I don't know how do I make this my screen size. Right. Okay. Let me just add a sub viewport to it. And this clear mode is never um always. We always update it. We're going to disable 3D. Um, I'm just going to create a color rect. So we have what we had before. And this color rate is going to be a full screen. So this sub viewport, I need this sub viewport to be a full screen. Seven 20. That's too much. 6 8. It's too much. 600. 650. Okay, 650. Let's say 720. 1,000. 1,200. 1,150. me see. What size is that in? 1,200. Are we for real? 1,009. Oh, I'm just skipping from 1,000, listening to 1,000. I'm a funny guy. 120, 150. Wait, let me shrink it to see whether we are the exact size. The size does matter in this exact situation. Okay. So this is our full Windows resolution. Okay, I don't know what this is, so I'm just going to detach it. Touch, not reload. So we should just say a white rectangle if all is well. Yes. So now I'm going to add that shade I just wrote to this rectangle. Um, with material, material, shader material, load shader, open. So I think that's the name of shader. So if I come to 2D now, ah, what's going on? Um, this has to be one so that it's not big. Okay. So I will be a hero, baby. So with the UV, basically what is happening is that we have majority of this color, that's mixture of red and blue here, and we have zero green. And the more we go this way, we get more green until it turns white. So that's basically what is going on. All right. So the first thing we need to do is that we need to make a grid. And yesterday we made a grid. If I can remember carefully, we made a grid by having a floating point number. Um, we called it row. We had another floating point number. We called it colon. And we set colon equals to row. If I say row, colon is equals to UV dot um, x multiplied by 10. That's what column is equal to UV dot x multiplied by 10. And I think that's just good. Let me just see. And row is just UV dot y multiplied by 10. Okay. So Then we also have a value that is for the borders that for the borders we use a step function. We create a step function of ish. Basically, we're trying to create a function that will say if row this is my brain is just a basket. I solved this yesterday and I can't remember. We have a step function that if row comma okay, not row, let's say UV. No, I can't use UV. Uh oh my gosh. Oh, basically what we're trying to do is that we're trying to have a step function that we're going to use a flow in it and we're going to say something like do I need the flow? Basically, what we're trying to say is that if so at row equals to 10, colon equals to 10, at row equals to we're just going to have the color be equals to black. So basically we want a function that we just compare either of the two. What am I saying? Oh shit. My guy, Usas, my guy. This is painful that we are not getting better. Or at least we're not getting as good as I need us to get, as fast as I need us to get there. Because like I'm trying to draw a grid with the shader and I can't even figure that out. Like how am I going to make the game of life if I can't even figure out how to draw a grid? Let's just create a float grid row colon vertex colon. Okay, no, to do the grid, we are going to have It's going to be something like we're going to convert. We're going to have a checker that's going to check is is um is row or column equal to n, or is equals to 20, or is equals to 30, or is equals to 40, or is equals to 50. So if it's equal to any of those values, the grid color is going to be uh, let's just have our grid color as black. I think that's the first thing. Our grid color is black. So that's Vic 4, and the color of black is Vic 3 of 0, comma 1. That's our grid color. What's going on? Okay, point 0, point 0. So, oh yeah, this is not a float, this is a Vic 4. Now, so this is the state of things. Now, instead of having this like this, we're going to have a mix statement, a mix, and we're going to give grid as a second parameter here, and we're going to put 1, and we're going to just cover this up. Let's put 0. So by default, let's make this green instead. RGB 0.0. This one. Okay, so we have our green grid, boring. I mean green stuff. So we now need to create a condition that's going to change this value of 1 or 0 from 0 to 1. So that's how we're going to make grid. We're going to have to change this value to 1 only in cases where only for situation where uv.x and uv.y is a whole number. Now, I know that we can achieve this using some kind of fract. I think it's using fract. Fract is a let me see. Let me make sense of that in my head. Can I use fract to do perform that task? Fract is a function that takes a number, disregards the whole number, keep keeps and returns the decimal. So while we fract, help us draw grid. It wouldn't. basically, Sha, I know that this last function is going to be a float grid points. Let's say grid points. And let's assign a step function to it. Step. Um, give it the value of, for now, just give it uv dot uv dot x, comma, um, let's give the value. I think we're looking for a place solution where frac is kind of let's say, okay, so instead of giving it this, let's give it row where frac is equal to 99. Wow, it tolerates that. Can I do a double step function? What I want to do is, so basically, um, so this is what I'm trying to achieve. I don't know whether I'm going about achieving that. Let's say if I put 2.0, hopefully fract is going to return the fractional part as a floating point number or wherever. And that floating point number is going to be a number. It's not at the end of the day, I don't think that fract is going to return a floating point number higher than the value. Sorry. Okay, yeah. Yeah. So now we just need to do this twice. What happens if I I was a girl in the village doing alright. And I became a princess overnight. So now we just need two step functions to make this great point actually come alive. So much to learn and see. Up in my castle with my new family. A whole new world is waiting for me. I'm so excited to be. Maybe I'll use the clamp function. Is it clamp? No. I'm not going to use clamp. But let me check it out. What does the clamp function do? I need a select function. That is a function that will allow me select if any of them is equals to one. Select. Let me check the clamp function. Shader. Shader language. Use this page. Next. Degree radians. Clamp. With clamp? Okay, clamp. Clamp. Clamps x between. Clamp. Okay. So we give the value of x if we don't have our minimum or maximum value. Okay, no, let's use clamp. Mm, or do I multiply the step function? I think I should multiply the step function. No, if I multiply the step function and any of the step function is outputting zero, our output is going to be zero. So obviously it's not the multiplying the step function is wrong. We want a situation where if any of our step function is one, the output be one, else the output be zero. I don't want to use an if statement to do this. Well, let's do the multiplication first. Step. And let's do frac and have colon, comma, 0.09. You see, this is the issue. So basically, instead of having is going to be zero. So we need another mathematical relation that's going to make it one at whenever they are one. If any of them, either of them is one, not when both of them are one. And multiplication is when both of them are one. If we use addition, we're going to get we're going to sometimes get a value that's going to be larger than oh, it looks good. One, two, three, four, five, six, 7, 8, 9, 10. But okay, this is the issue I have. It works, but like it's wrong. Like, or is it that I'm not thinking? If we use addiction to make the grade, if we use addiction to make the grade, then we are basically saying that if any of them is one, grade points. If both of them are one, grade points will be equals to two. Uh, but this mix works by saying having a value between zero and one, and saying that we're going to flip. If this value is less than zero, we have this. But if this value is greater than zero, we have this. So why is it working? Only God knows. What I can do is I can give it to AI to mark it. I can give it to AI to mark it, and AI is going to tell me whether it's just a happy accident. Is this a correct CORRETCION? So CORR. Is this a correct way? No H. Is this a correct way to draw a grid? You have a completely valid, highly efficient way of drawing a grid. In fact, doing it this way procedurally in fragment shader is industry standard based to scale perfectly regardless of the resolution and use very easy processing power. However, while your logic is sound, there is a small visible bug in how you are mixing the color and a few ways you can optimize it. One catch, the one catch, the color flips. In your mix function, you have your color slightly backward if you want green grid on a black background. Grid points will be 1.0 true where the grid line are and 0.0 false where the stuff as empty mix A B with returns A when 0 and B when 1. Yes, that's what I want. Right now your code draws the green squares with black grid. If you want your code to draw a green grid with black background, you need it. Why would I swap that? Okay, exactly. This is what I needed. I needed max. If the pixel falls within okay. So it's max I need, not an addition. Let me just swap this to a common sign because that's what I need. I need if I don't know why it didn't come to my head. I want to say if anyone is one, the whole value should be one. And I think max is a perfect function for that because max gives you the highest value. So if one is zero and the other one is one, we're going to get one as the output. If both are zero, the output is going to be wait, no. If both are zero, what does max give you? The highest value between A and B. Oh, if both are zero, it gives you zero. So it was max I needed all along. So this is the grade. So now the next thing to do is to create that game of life That is, we're going to um create a way to check. We're going to first randomize the scene. So this is something that I've never seen before, but I'm going to just ask a question. Practice your best. Why this approach is great? Practice your best friend. You repeat the 0.0 to 1.0 space over which is mathematically perfect grid. Uh, Max streak. If you want to make this genuinely useful for game programming, you should turn those hard-coded value of 10 and 0.9 into uniform so you can change the grid size and grid thickness on the Godot. That does not concern me yet. Right now, what I want to do is let's see ah okay, yes, random. Is there a random function in shader? I'm proud of myself that I was able to get the grid, even though I couldn't figure out the marks, or I was not patient enough to figure out the marks because it worked without the marks. Yes, but not the way you think. Unlike standard programming language, GLS, the shader language uses Godot. Using Godot does not have an inbuilt or random variable function. Doesn't have any random because shaders run on the GPU. They must be completely deterministic. If a pixel of a specific coordinate asks for a random number, it needs to get the exact same random number every single frame. Otherwise, the screen will look like a chaotic flashing TV. To get around this, shader developers use pseudo random number generator. This function, it uses a mathematical formula to turn a coordinate like your grid into a chaotic unpredictable number between 0 and 1. This is not there's nothing random about a sine function of UV. This is not random. How to use this? If you want to make the grid more interesting, for example, give each cell a random brightness. You can feed the integer the integer part of your grid coordinates into the random function. Okay. So no, that's not the task at hand. So the task at hand is that I want to build a game of life. Don't give me code. The task at hand is I want to build a game life where I initialize the shader with a random random what now? Oh my god, so think. random cell call. I said, don't give me code. Are you deaf? Oh, I said, do give code. Hmm. Ah, don't. To build a game of life shader with random initial states, you need to approach the problem a bit different than traditional programming. Shaders don't have persistent memories that stays around from frame to frame by default. They are just calculated colors based on input. To make a game of life work, you need two distinct phases: initialization, the random setup, and simulation, the loop that counts the neighbor and applies the rule. Here is a conceptual breakdown of how to structure this without writing a single line of code. The strategy: two shader or multi-pass shader. You cannot do this in a single standard fragment shader because a standard shader resets every frame. To make a game loop, you need the output frame one to become an input of for frame two. In Godot, this is usually achieved by using sub viewport and back buffer. Yes, I forgot to add the back buffer node. Um, add back buffer create. So okay, let's return back and understand what he's trying to say. So, back buffer creating a feedback loop. Shader A, okay. Shader A, the initializer, runs exactly once at the very start of the game. It uses a pseudo random function to generate a grid of random black, dead, and white or colored alive pixels. I don't like when I'm counting my word when I read. Should that be? The simulation runs every frame after that. It reads the pixel from the previous frame, counts the neighbor, and calculates the next frame. Alternatively, you can continue these into one shader by using a custom uniform Boolean initializing switch controlled by GD script and alternatively, you can combine this into one shader by using a custom uniform bool initializing switch controlled by GD script. When initializing it is true, it runs the random logic. When false, it runs the game logic. Phase one, random initialization logic. So seed your word, your map will you will map your grid into a pseudo-random mathematic math function we discussed earlier. The grid breakdown, you need to look at the pixel as discrete cells, not smooth gradient. You achieve this by rounding the coordinate. Bro, stop telling me what to do. I know how to achieve. Look at rounding your coordinate function using a floor function. This ensures that every pixel inside cell 53 gets the exact same random value. Okay, so I need to create a pseudo random function. Let me just copy the pseudo random value function. Where is it? Pseudo random. So personally, I don't see why this is a random function, especially as we're not multiplying with time. You will work it. like machines do. Dun, 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 dun. You found a dream. Dun, 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 dun. Is it too late? Dun, 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 dun. I don't believe any of it. Yeah. You will walk in. Dun, 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 dun. Dun, 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 dun. Okay. If I continue copying, I will be doing myself a. You will walk in. Dun, 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 dun. You found a dream, like machines do. Dun, 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 dun. So we want to floor a vec to value of colon comma. You will work in dun 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 like machines do. Dun, 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 dun. Okay, Jesus. Jesus imirime kirevum onanuru muteme Jesus imirime kirevu oromuteme oromuteme Jesus imirime kirevum onanuru muteme Jesus emirime kirevu oromuteme oromuteme Jesus emitami Jesus irime. Mm. Okay. Onana runa runa romut Jesus sirime 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 oromuteme orom. Okay, let's just see how um the whole thing would look if I were to now Control C assign this value here. We can't just do that because this is returning a vector. So first and foremost, we need to return at least a vec3 or a vec4. We need to return a vec4. Oh, let's see. How do you think of it? Okay, control. Okay, let's read what they asked me to do. Then phase one, um the grid breakdown. You need to look at your pixel as discrete cells, not a smooth gradient. You can achieve this by floor. Okay, I have done the floor of my stuff. Then using a sub viewport or a back. No, this is not what I'm reading. Again, law function, blah, blah. The threshold point flip. Your skin is so beautiful. Okay. Um. The threshold, the coin flip. The random function outputs a smooth value between 0 and 1. To turn this into a binary, alive or dead state, you want a 30% chance of a cell to start alive. You, for example, if you want a 30% chance, you check if the random number is less than 0.3. If it is, paint the color. If not, paint it black. Okay, first of all, I think that my okay. So this value that we get is a vector matrix that can be of any value from a vector 2 that can be of any value from 0. Let me just see what I'm working with. Because if I don't know what I'm working with, okay, so I can just put cell, random cell value, wrap it in a vec, wrap it in a vec 4, then put a comma, another random cell value. No, no. Why can't I do this? Oh, sorry, it returns a float. So I literally can just put only one. Are you in the Lord's army? Are you in the Lord's army? I will never steal from my mommy. Oh, yeah, we are comparing a float. Oh, what may seem to be the issue, please? I will never steal from my mommy's phone. Tell lies to daddy. Beat up my younger one. I will never fight in my neighborhood. I am in the Lord's army. Are you in the Lord's army? Are you in the Lord, Sammy? So now what I need to do is now just have a threshold value for this. If this value, if this floating point number is less than 30%, I like the screen to be green. If it's more than 30%, I keep it as so let me just green RGB. That's 0.0, comma 0.1, 1.0, comma 0.0, comma 1. Okay. So instead of hard coding this value, I'm going to come here, Control C, and I'm going to come here. I'm going to just uh, say this is a cell. Sorry, I'm going to give this a vector 4. I'm going to call it BG color, and I'm going to give it the value of our cell. I'm just going to change this to BG color. Then I'm going to say BG color is going to be a smooth step. I think a smooth step is what the best for this. A smooth step. A smooth step compares vec a vec smooth step of um green and then let's see green and whites of a C value of 0.3. No, sorry. I really don't need a smooth steps. Do I? Let's 1.0, 0.0. No, 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 no. Okay, I did not think about this. BG color. Okay, so we want a smooth step to determine if this value, this exact variable is going to be 0 or 1, 0 or 1. So we just come here now and say smooth step, smooth step. Then we're going to have we're going to impute our cell random value. We don't even need a smooth step. A simple step is going to do. Even though I would have been so I want to see how a smooth step works, and we're just going to put 0.3. Okay. Do do do. I think it's a fine color. So Control A, Control C. Um, um, on the right track. I know I'm on the right track. I don't know why I need this validation. Okay, said yes, you are exactly on the right track. You have successfully connected the concept of grid coordinates, quantization law, using the threshold step to create a binary alive or dead state of your cell. Here's a breakdown. Cell isolation. By using floor, vector, blah blah blah, you ensure that every single pixel inside the specific 10 by 10 grid shares the exact same cell ID. This stops randomness from looking like fine TV statics, coin flipping. Your step is perfect because random output a value of 0 to 1. The line translates to give this cell a 70% chance of being active, returning 1, and a 30% chance of being inactive, returning 0.0. Next hurdle, if you run this code now, you see a BTV randomized gate. However, you will notice two problems when you try to turn this to an actual game. It's static. The random layout will be identical every time you launch the game. It overrides the future because the code sits directly in the fragment shader. The function private function without any condition. It will recalculate the randomness every single frame. If you try to write the simulation logicness, the initialization code constantly overrides it. How to adapt this to a game of life? To fix these two issues, prepare for and prepare for the actual simulation. You will need to introduce a uniform variable passed from Godot to this script. Add a seed true randomness. To stop the grid from looking identical every launch, you can pass a random number like the system time from Godot into the uniform cell ID into the into a uniform and add it to the cell ID before passing it to the random function. Okay. You need a way to tell the shader only do the random layout on frame 1, then switch to simulation mode. You can do this with a boolean uniform. If initializing is true, run your current code. Else, if else initialization is false, stop generating random number. Instead, look at the pixel around. Okay, yeah. So I didn't need to use okay. So basically, what it's trying to do is do uniform, let's say system time, and this is I think it's a float. Uniform uh in um I want a uniform checkbox. I know it's hints. Uniform bool. Let's first do uniform bool. Um, let's say init. We want it to be a hint. How do we use these hints? Let's check the doc. think it is previous. I need to check. Mm, I found the love stronger than anything. Okay, so the hint here. He shares my dream and so one hint checkbox. I'll share her home. I found the love to carry more than just a family. To carry love, carry children of our own. We were just kids when we fell in love, not knowing what. Well, if I can't find checkbox, I'll just have to expose a hint of 0 and 1. I wouldn't give you all this time, darling. Just give. Oh, so I don't even need to. I don't need to give it a hint. Godot to just turn into a checkbox. Gonna delay. Experience is the best teacher. Okay, okay, okay. So this system time now, I can now come here, maybe attach a program, attach script for a get time. But time is not actually instead of getting time. Let's just get random. Let's make this a tool. Ads. So extend node. And basically what I want to do is that I just want it doesn't need a process function. I just want a I just want a way to say um if wait no first I need to get color rect. I don't even know how to write GT script if I'm being honest. How do you write GT script now? Luckily we have it right. We have some example GT script. Okay, I'm ready. Okay, this is even the one I need. already Control C. Okay, so I can just go back to where I was just now. Control V. And I can just say let's say floats. Let's just call it, let's just have a variable and is equals to we're just going to have a random random I think random floats. Let me first screen this. Okay, random floats. Random floats returns a floating point value between 0.0 and 1.0. Okay, so when we're using it, we know that okay, this value is around 0.0 and 1.0. Save. So we want a random float. We want already if um color it. Let's call it if grid. If grid shader parameter. Something let me how do we reference it? Shader parameter is initialized. Shader I don't think I'm doing this right. I know I'm not doing this right. I know that okay. Let's just trust my gut feeling. Get rid of this grid dot shader parameters. Falling inside another hole. need to learn Godot. Mm-mm-mm-mm. Let me change this value from system time to bless the Lord, my soul. I think it's something like a dollar sign. It's a new day done. Time to see what my your pseudo script is a great starting point for GD scripts. Okay, it's actually this get shader parameter. Okay, grid material dot material dot shader parameters get shader parameter. Then the other one will be set shader parameter. I need you to hold on. Heaven is a place not too far away. Dun, 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 dun. We all make mistakes. How do you do vector? I don't care if I Be merciful unto me, O Lord. Be merciful unto me, O Lord. Be merciful. Be merciful. For my soul trusted. My soul trusted in the Savior, in the shadows of the weak. Mhm. For me, I ready to implement the await get tree dot process function line right after the switch is initialization to false. Oh, my soul trusted, my soul trusted the Savior in the shadows of the I think the whole point of making this an editor code is that it should run in the editor. I mean, two code that should run as a tool. Okay. Why can't I hear anything?
behaviors. You might want to test different parameters until you get the desired values. This typically involves going back and forth, changing the parameters, and hitting the play button to observe the changes. A better
Okay, process function. Do 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 do. This is what I expected to happen since do because basically we're checking if this is true. If it's true, we should change the value. But since that it is true, the value is just changing. Do 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 do. Do 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 do. So now from this point, but there's something I have noticed. It has a bias to be um this light shade. But regardless, let's say focus more on the shade as we are not here to focus on I know I mean the issues from the shade aside. I think is this step function. If I were to come here now and swap, maybe change this to let's say 9. Then take care. If I change it to 5, we should even see the changes instantly. Yeah. Dun 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 dun. Dun 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 dun. Dun 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 dun. So now we need to now get the logic for the game of life. So so basically what the game of life does is that it looks at this pixel and says I am white. Let me see if I can on my mouse that week. I've not even gone into like special effects or something. That is my accomplish. Ish, ish, ish. I don't think I should have used spare cards to check it. The successfully lockdown phase one. Your shader now accepts random seed vector from your GDA process and it's into a beautiful seller script, blah 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 blah. Task two, task one. Yeah, here's a roadmap to achieve. Task one, the GD script handshake turn off. Right now, your shader is generating random cell on a loop forever. You need to update the GD script ready function to execute a quick sequence, pass a random vector, set up a await tree to let the GPU render that random frame once. Set is initializing to false. I do not care about that. Set the feedback loop. The viewport texture, because the shader cannot naturally remember what it drew on the previous frame, you need to feed its own output back to itself. In the else block of your shader where its initializing is false, you need to fetch the color of the current cell from the previous frame. Okay, okay, so basically what I just need to do is actually no, no, no. Why is the unexpected initialization of a constant? Can't I initialize a constant? This is not how it's done at all. Begging, begging you. I don't even understand how to position variable that will not disturb each other. I have a lot to learn.
Are we setting viewport sides from here? So what are we seeing? We are seeing create a clickable button, the inspector called reset. When you click the reset button, it triggers the editor to edit engine. Let's look at the shader code. Let me ask anti-gravity was the problem. Structured manner. So that I don't continue depending on AI, I think I need to use a book. Have a book that has It just changed my code. Ah, okay, let's read it. So what we're doing is that we are. Oh, wait. One day I will understand this shit, but that day is not today. She, I mean, Jackie Chan. I'm not buying any book. Oh. No, I cannot. Why I want to see money? It's illegal download. Okay, so in my free time, I'll read this stuff. Oh wait, 'cause this night I don't have energy to read it. Can I read more? Reading mode. Hmm.
cool.
its weird conventions. For that, I recommend taking a look at openglebook.com/chapter-0-preface-what-is-opengle.html. Why are shaders famously painful? As Uncle Ben said, with great power comes great responsibility, and parallel computation follows this rule. The powerful architectural design of the GPU comes with its own constraints and restrictions. In order to run in parallel, every pipe, or thread, has to be independent from every other thread. We say the threads are blind to what the rest of the threads are doing. This restriction implies that all data must flow in the same direction. So it's impossible to check the result of another thread, modify the input data, or pass the outcome of a thread into another thread. Allowing thread-to-thread communications puts the integrity of the data at risk. Also, the GPU keeps the parallel microprocessor, the pipes, constantly busy. As soon as they get free, they receive new information to process. It's impossible for a thread to know what it was doing in the previous moment. It could be drawing a button from the UI of the operating system, then rendering a portion of sky in a game, then displaying the text of an email. Each thread is not just blind but also memoryless. Besides the abstraction required to code a general function that changes the result pixel by pixel depending on its position, the blind and memoryless constraints make shaders not very popular among beginning programmers. Don't worry. In the following chapters, we will learn step by step how to go from simple to advanced shading computations. If you are reading this with a modern browser, you will appreciate playing with the interactive examples. So let's not delay the fun any longer and press next greater than to jump into the code. Hello World. Usually the Hello World example is the first step to learning a new language. It's a simple one-line program that outputs an enthusiastic welcoming message and declares opportunities ahead. In GPU land, rendering text is an overcomplicated task for a first step. Instead, we'll choose a bright welcoming color to shout our enthusiasm. If you are reading this book in a browser, the previous block of code is interactive. That means you can click and change any part of the code you want to explore. Changes will be updated immediately thanks to the GPU architecture that compiles and replaces shaders on the fly. Give it a try by changing the values on line 8. Although these simple lines of code don't look like a lot, we can infer substantial knowledge from them. 1. Shader language has a single main function that returns a color at the end. This is similar to C. 2. The final pixel color is assigned to the reserved global variable gl_frag color. 3. This C-flavored language has built-in variables like gl_frag color, functions and types. In this case, we've just been introduced to vec4, that stands for a 4-dimensional vector of floating point precision. Later we will see more types like vec3 and vec2 together with the popular float, int and bool. 4. If we look closely to the vec4 type, we can infer that the 4 arguments respond to the red, green, blue and alpha channels. Also, we can see that these values are normalized, which means they go from 0.0 to 1.0. Later, we will learn how normalizing values makes it easier to map values between variables. 5. Another important C feature we can see in this example is the presence of preprocessor macros. Macros are part of a pre-compilation step. With them, it is possible to #define global variables and do some basic conditional operation with #ifdef and #endif. All the macro commands begin with a #hash. Pre-compilation happens right before compiling and copies all the calls to #defines and check #ifdef is defined and #ifndef is not defined conditionals. In our Hello World example above, we only insert the line 2 if gl_s is defined, which mostly happens when the code is compiled on mobile devices and browsers. 6. Float types are vital in shaders, so the level of precision is crucial. Lower precision means faster rendering, but at the cost of quality. You can be picky and specify the precision of each variable that uses floating point. In the second line, precision medium float winking face, we are setting all floats to medium precision. But we can choose to set them to low precision low float winking face or high precision high p float winking face. 7. The last, and maybe most important, detail is that GLSL specs don't guarantee that variables will be automatically casted. What does that mean? Manufacturers have different approaches to accelerate graphics card processes, but they are forced to guarantee minimum specs. Automatic casting is not one of them. In our Hello World example, VEC4 has floating point precision, and for that it expects to be assigned with floats. If you want to make good consistent code and not spend hours debugging white screens, get used to putting the point in your floats. This kind of code will not always work. Main GL_frag color equals VEC4 1 0 0 1 error. Now that we've described the most relevant elements of our Hello World program, it's time to click on the code block and start challenging all that we've learned. You will note that on errors, the program will fail to compile, showing a white screen. There are some interesting things to try. For example, try replacing the floats with integers. Your graphic card may or may not tolerate this behavior. Try commenting out line 8 and not assigning any pixel value to the function. Try making a separate function that returns a specific color and use it inside main. As a hint, here is the code for a function that returns a red color. VEC4 red. Return VEC4 1.0, 0.0, 0.0, 1.0. Closing curly bracket. Types, try to discover other ways. The following is one of them. VEC4 color equals VEC4 VEC3 1.0, 0.0, 1.0, 1.0. Although this example isn't very exciting, it is the most basic example. We are changing all the pixels inside the canvas to the same exact color. In the following chapter we will see how to change the pixel colors by using two types of input: space, the place of the pixel on the screen, and time, the number of seconds since the page was loaded.
I want to test this.
Uniforms. So far we have seen how the GPU manages large numbers of parallel threads, each one responsible for assigning the color to a fraction of the total image. Although each parallel thread is blind to the others, we need to be able to send some inputs from the CPU to all the threads. Because of the architecture of the graphics card, those inputs are going to be uniform to all the threads and necessarily set as read only. In other words, each thread receives the same data which it can read but cannot change. These inputs are called uniform and come in most of the supported types: float, VEC2, VEC3, VEC4, MAT2, MAT3, MAT4, Sampler 2D and Sampler Cube. Uniforms are defined with the corresponding type at the top of the shader right after assigning the default floating point precision. #ifdefgl_s. Precision medium p float. #endIfUniform VEC2U_resolution. Canvas size width, height uniform VEC2U_mouse, mouse position in screen pixels. Uniform float U_time, time in seconds since load. You can picture the uniforms like little bridges between the CPU and the GPU. The names will vary from implementation to implementation, but in this series of examples I'm always passing U_time, time in seconds since the shader started, U_resolution, billboard size where the shader is being drawn, and U_mouse, mouse position inside the billboard in pixels. I'm following the convention of putting U_ before the uniform name to be explicit about the nature of this variable, but you will find all kinds. Uniforms are defined with the corresponding type at the top of the shader right after assigning the default floating point precision. #ifdefgl_s. Precision medium p float. #endIfUniform VEC2U_resolution. Canvas size width, height uniform VEC2U_mouse, mouse position in screen pixels. Uniform float U_time, time in seconds since load. You can picture the uniforms like little bridges between the CPU and the GPU. The names will vary from implementation to implementation, but in this series of examples I'm always passing U_time in seconds since the shader started, U_resolution, billboard size where the shader is being drawn, and U_mouse position inside the billboard in pixels. I'm following the convention of putting U_ before the uniform name to be explicit about the nature of this variable, but you will find all kinds of names for uniforms. For example, shadertoy.com uses the same uniforms but with the following names. Uniformvec 3i solution. Viewport resolution in pixels. Uniformvec 4i mouse. Mouse pixel chords. XY. Current. ZW. Click. Uniform float time. Shader playback time in seconds. Enough talking. Let's see the uniforms in action. In the following code we use U_time, the number of seconds since the shader started running, together with a sine function to animate the transition of the amount of red in the billboard. As you can see, GLSL has more surprises. The GPU has hardware accelerated angle, trigonometric and exponential functions. Some of those functions are sin, cos, tan, asin, acos, atan, pow, express, log, sqrt, abs, sine, floor, seal, fract, mod, min, max, and clamp. Now it is time again to play with the above code. Slow down the frequency until the color change becomes almost imperceptible. Speed it up until you see a single color without flickering. Play with the 3 channels RGB in different frequencies to get interesting patterns and behaviors.
Rising there, that's 1 and a 5. I first saw this pattern that I'm about to show you in a question on the Math Stack Exchange. What the user had been doing was playing around with data in polar coordinates. The pattern that we'll look at centers around plotting points where both of these coordinates are a given prime number. It initially looks quite random. After all, primes are famous for their chaotic and difficult to predict behavior. But when you zoom out, what you start to see are these very clear galactic-seeming spirals. And what's weird is some of the arms seem to be missing. And zooming out even further, those spirals give way to a different pattern. these many different outward-pointing rays. I first saw this pattern that I'm about to show you in a question on the Math Stack Exchange. What the user had been doing was playing around with data in polar coordinates.
When I finish up, like I first saw this question, I'm about to show you in Ben Stewart or whoever that this guy is. Okay, let me see. Let's talk about how we can draw this with shader. I'm going to go back to the book, but not now. I'll read it off stream. No, don't write code for me. Do not write code for me. So let's draw this, then by 5 we just play chess and call it a day.
Mapping the Ulam spiral inside a shader without using loops or arrays is a brilliant mental puzzle. Since shaders run in parallel for every single pixel, we can't draw the spiral chronologically from 0 outward. Instead, we have to do the inverse. Given a coordinate, x, y, we must mathematically calculate exactly which step of the spiral we are on. To achieve this purely with math, we break the problem down into concentric layers, vector distances, and direction shifts. 1. The coordinate setup, the canvas. First, we need to transform the standard UV coordinates, which usually run from 0 to 1, into a centered grid. Centering, shift the origin, 0, 0, to the exact center of the screen. Scaling and quantizing, multiply the coordinates by your desired grid size, e.g., a 11 times 11 grid, and use a floor function. This turns smooth screen space into discrete, pixelated integer blocks, x, y. 2. Finding the layer, the shell. The Ulam spiral wraps around itself in square, shells, or layers. Step 0 is the center. Layer 1 contains steps 1 through 8. Layer 2 contains steps 9 through 24, and so on. To find which layer a coordinate, x, y, belongs to, we use Chebyshev distance, maximum absolute distance from the center. This instantly tells us how far out we are. For example, the coordinates 2, minus 1, 2, 2, and minus 2, 0, all belong to layer 2. 3. The math of the spiral base. Every time a layer completes, the total number of steps accumulated follows a strict mathematical pattern based on odd squares. Layer 0 ends at step 0, 1 carried 2 to 1. Layer 1 ends at step 8, 3 carried 2 to 1. Layer 2 ends at step 24, 5 carried 2 to 1. Therefore, the maximum step value of the previous layer, n1, can be found using. This gives us a launching pad. If our pixel is in layer 2, we know the spiral for this layer starts counting right after the end of layer 1, step 8. 4. Determining the segment and progression. Once you know the layer, you need to figure out which of the 4 sides of the square shell the coordinate sits on. Right, top, left, or bottom. This is where vector directions and conditional logic come into play. Depending on which side the coordinate falls, you calculate how far along that specific segment the pixel is. Right wall, moving up. Top wall, moving left. Left wall, moving down. Bottom wall, Moving right.
Not to this
By
thing.
comparing X
Uniforms are defined with the corresponding type at the top of the shader right after assigning the default floating point precision. Hashtag ifdefgl_s. Precision medium p float. Hash endif uniform vec2u_resolution. Canvas size width, height uniform vec2u_mouse position in screen pixels. Uniform float u_time, time in seconds since load. You can picture the uniforms like little bridges between the CPU and the GPU. The names will vary from implementation to implementation, but in this series of examples I'm always passing u_time, time in seconds since the shader started, u_resolution, billboard size where the shader is being drawn, and u_mouse position inside the billboard in pixels. I'm following the convention of putting u underscore before the uniform name to be explicit about the nature of this variable, but you will find all kinds of names for uniforms. For example, shadertoy.com uses the same uniforms but with the following names. Uniform vec 3i solution. Viewport resolution in pixels. Uniform vec 4i mouse. Mouse pixel chords. XY. Current. ZW. Click. Uniform float time. Shader playback time in seconds. Enough talking, let's see the uniforms in action. In the following code we use u_time, the number of seconds since the shader started running, together with a sine function to animate the transition of the amount of red in the billboard. As you can see, GLSL has more surprises. The GPU has hardware accelerated angle, trigonometric and exponential functions. Some of those functions are sin, cos, tan, asin, acos, atan, pow, express, log, sqrt, abs, sine, floor, seal, fract, mod, min, max, and clamp. Now it is time again to play with the above code. Slow down the frequency until the color change becomes almost imperceptible. Speed it up until you see a single color without flickering. Play with the 3 channels RGB in different frequencies to get interesting patterns and behaviors. GL_frag chord. In the same way GLSL gives us a default output, vec4gl_frag color, it also gives us a default input, vec4gl_frag chord, which holds the screen coordinates of the pixel or screen fragment that the active thread is working on. With vec4gl_frag chord, we know where a thread is working inside the billboard. In this case we don't call it uniform because it will be different from thread to thread, instead gl_frag chord is called a varying hollow up pointing triangle. In the above code we normalize the coordinate of the fragment by dividing it by the total resolution of the billboard. By doing this the values will go between 0.0 and 1.0, which makes it easy to map the x and y values to the red and green channel. In Shaderland we don't have too many resources for debugging besides assigning strong colors to variables and trying to make sense of them. You will discover that sometimes coding in GLSL is very similar to putting ships inside bottles. Is equally hard, beautiful and gratifying. Now it is time to try and challenge our understanding of this code. Can you tell where the coordinate 0.0, 0.0 is in our canvas? What about 1.0, 0.0, 0.0, 1.0, 0.5, 0.5 and 1.0, 1.0? Can you figure out how to use u_mouse knowing that the values are in pixels and not normalized values? Can you use it to move colors around? Can you imagine an interesting way of changing this color pattern using u_time and u_mouse coordinates? After doing these exercises you might wonder where else you can try your new shader powers. In the following chapter we will see how to make your own shader tools in 3.js, processing, and open frameworks. Less than previous. Home. Next greater than. Copyright 2015 Patricio Gonzalez Vivo.
And you underscore mouse.
Oh, no, yours is mine is big too. Okay, wait. I am alpha, so if I go down here, okay, just need to put sign of it.
Now it is time again to play with the above code. GL_frag chord. In the same way GLSL gives us a default output, vec4gl_frag color, it also gives us a default input, vec4gl_frag chord, which holds the screen coordinates of the pixel or screen fragment that the active thread is working on. With vec4gl_frag chord, we know where a thread is working inside the billboard. In this case we don't call it uniform because it will be different from thread to thread, instead gl_frag chord is called a varying. 1. Hashtag ifdef gl_s. Precision. Hashtag and if. 5. Uniform vec2u_resolution. Uniform vec2u_mouse. Uniform flow2_time. Void main. gl_frag chordu_resolution. gl_frag coloru_mouse u_time. In the above code we normalize the coordinate of the fragment by dividing it by the total resolution of the billboard. By doing this the values will go between 0.0 and 1.0, which makes it easy to map the X and Y values to the red and green channel. In Shaderland we don't have too many resources for debugging besides assigning strong colors to variables and trying to make sense of them. You will discover that sometimes coding in GLSL is very similar to putting ships inside bottles. Is equally hard, beautiful and gratifying. Now it is time to try and challenge our understanding of this code. Can you tell where the coordinate 0.0, 0.0 is in our canvas? What about 1.0, 0.0, 0.0, 1.0, 0.5, 0.5 and 1.0, 1.0? Can you figure out how to use u_mouse knowing that the values are in pixels and not normalized values? Can you use it to move colors around? Can you imagine an interesting way of changing this color pattern using u_time and u_mouse coordinates? After doing these exercises you might wonder where else you can try your new shader powers. In the following chapter we will see how to make your own shader tools in 3.js, processing, and open frameworks.
Okay, wait. If the mouse position are in pixel, they are not normalized. It means that the mouse position will be whatever the screen resolution is. Well, that's the maximum value of whatever the screen resolution is.
Why is it not working? Oh, so they normalized. This is what I wanted to do. Na 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 na. Jesus, Jesus, God. Jesus, God. How do you use UV in this stuff? How do you do? Okay, this should give me UV. I think that's the equivalent of UV. I had a dream. I had everything I wanted. Know what you think. It was definitely what I wanted. It could have been a nightmare. Spending those on my key. It's very similar to Godot tone. Wish I could change.
Running your shader. As part of the construction of this book and my art practice, I made an ecosystem of tools to create, display, share, and curate shaders. These tools work consistently across Linux, Mac OS, Windows, and Raspberry Pi and browsers without the need of changing your code. Running your shaders on the browser. Display. All live examples in this book are displayed using GLSL Canvas, which makes the process of running standalone shader incredibly easy. Canvas class equals GLSL Canvas, data fragment URL equals your shader, frag data textures equals your input image.png, width equals 500, height equals 500, greater than less than canvas. As you can see, it just needs a canvas element with class equals GLSL Canvas and the URL to your shader in the data fragment URL. Learn more about it here. If you are like me, you will probably want to run shaders directly from the console. In that case, you should check out GLSL Viewer. This application allows you to incorporate shaders into your bash scripts or Unix pipelines and use it in a similar way to ImageMagick. Also, GLSL Viewer is a great way to compile shaders on your Raspberry Pi, which is the reason OpenFrame.io uses it to display shader artwork. Learn more about this application here. GLSL Viewer your shader. Frag your input image.png, W500H500E screenshot, your output image.png. Create. In order to illuminate the experience of coding shaders, I made an online editor called GLSL Editor. This editor is embedded on the book's live examples. It brings a series of handy widgets to make more tangible the abstract experience of working with GLSL code. You can also run it as a standalone web application from editor.thebookofshaders.com/. Learn more about it here. If you prefer to work offline using Sublime Text, you can install this package for GLSL Viewer. Learn more about it here. Share. The online editor editor.thebookofshaders.com/closing parenthesis can share your shaders. Both the embedded and standalone version have an export button where you can get in unique URLs to your shader. Also, it has the ability to export directly to an OpenFrame.io. Curate. Sharing your code is the beginning of you sharing your shader as artwork. Beside the option to export to OpenFrame.io, I made a tool to curate your shaders into a gallery that can be embedded on any site. Its name is GLSL Gallery. Learn more here. Running your shaders on your favorite framework. In case you already have experience programming in a framework like Processing, 3, JS, Open Frameworks, or SFML, you're probably excited to try shaders on these platforms you feel comfortable with. The following are examples of how to set shaders in some popular frameworks with the same uniforms that we are going to use throughout this book. In the GitHub repository for this chapter, you'll find the full source code for these 3 frameworks. In 3, JS. The brilliant and very humble Ricardo Cabello, aka Mr. Do, has been developing along with other contributors probably one of the most famous frameworks for WebGL, called 3, JS. You will find a lot of examples, tutorials, and books that teach you how to use this JavaScript library to make algorithmic drawing. Shaping functions. This chapter could be named Mr. Miyagi's fence lesson. Previously, we mapped the normalized position of x and y to the red and green channels. Essentially, we made a function that takes a 2-dimensional vector x and y and returns a 4-dimensional vector r, g, b, and a. But before we go further transforming data between dimensions, we need to start simpler, much simpler. That means understanding how to make one-dimensional functions. The more energy and time you spend learning and mastering this, the stronger your shader karate will be. The following code structure is going to be our fence. In it, we visualize the normalized value of the x-coordinate street x in 2 ways, one with brightness, observe the nice gradient from black to white, and the other by plotting the green line on top. In that case, the x value is assigned directly to y. Don't focus too much on the plot function. We will go through it in more detail in a moment.
Smooth step. 0.2. There. Up to, wow.
Quick note, the vec3 type constructor understands that you want to assign the 3 color channels with the same value, while vec4 understands that you want to construct a 4-dimensional vector with a 3-dimensional 1 plus a 4th value, in this case the value that controls the alpha or opacity. See for example lines 19 and 25 above. This code is your fence. It's important to observe and understand it. You will come back over and over to this space between 0.0 and 1.0. You will master the art of blending and shaping this line. This one-to-one relationship between x and y, or the brightness, is known as linear interpolation. From here we can use some mathematical functions to shape the line. For example, we can raise x to the power of 5 to make a curved line. Interesting, right?
Okay, wait, what the heck is this? PC plot testing. Normally, this will make our gradient the mm, you're losing me, nigga. You're losing me.
Quick note, the vec3 type constructor understands that you want to assign the 3 color channels with the same value, while vec4 understands that you want to construct a 4-dimensional vector with a 3-dimensional 1 plus a 4th value, in this case the value that controls the alpha or opacity. See for example lines 19 and 25 above. This code is your fence, it's important to observe and understand it. You will come back over and over to this space between 0.0 and 1.0. You will master the art of blending and shaping this line. This one-to-one relationship between x and y, or the brightness, is known as linear interpolation. From here we can use some mathematical functions to shape the line. For example, we can raise x to the power of 5 to make a curved line. Author, Inigo Keelis. Title, Expo. 3. Precision medium p float. Hashtag define pi 3.14159265359. Uniform vec 2u underscore resolution. Uniform vec 2u underscore mouse. Uniform float 2 underscore time. Float block vec 2 stone. Float PCT. Return smooth step PCT 0.02 PCT street y. Smooth step PCT PCT plus 0.02 street y. Closing curly bracket. Vec2 stone equals GL underscore frag chord XY U underscore resolution. Floaty equals POW street by 5.0. Color equals 1.0 PCT color plus PCT asterisk vec3 0.0 1.0 0.0. 28, 29, 30. Closing curly bracket. 31. Interesting, right? On line 22 try different exponents. 20.0, 2.0, 1.0, 0.0, 0.2 and 0.02 for example. Understanding this relationship between the value and the exponent will be very helpful. Using these types of mathematical functions here and there will give you expressive control over your code, a sort of data acupuncture.
I'll do this later. That's quite a wraps for learning today. Mm. I want to try and work on my stream settings so that I can like So am I wrong for thinking that we could be something for real? But I could always do this. order, 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 order. Put them in order, order, order.
I'll sing of Jesus, I'll sing of him who passed away. Sharp. I'll sing of Jesus, I'll sing of him who passed away. Sharp. I'll sing of Jesus, I'll sing of him who passed away. Sharp. I'll sing of Jesus, I'll sing of him who passed away. Ah, shit. I found love stronger than anything. This is my dream, and there shall I found love. Yeah, well, what am I even playing? Ooh, I can't allow that move. I can't allow that move. Ah! I'm in trouble. Oh, how do I not lose this point? I'm 2 pawns down. Uh, What the hell that move? Wait, I'm not a pawn down again. Ah, what happened? Wait, again, let me see. Um, Ivana Wahala. Ivana Tusali. Ivana Wahala. Let's see. Bunny is a dinosaur from my imagination. This one, dinosaur sensation. Da, 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 da. Shake yeah, take yeah, take yeah. Greed they speak about in the Bible. Are we for real? ABC, I want to take. Are we serious? How did he manage to throw this his win away? It was clearly winning. A miss one a tactical opportunity. See now, the guy was clearly winning up until he threw away the win. Very poor game from me. When did I even start? Oh, I should have actually just captured that phone. I really played really poorly. Wait, explain. Show best. Okay. Okay, if I've kept my queen on the board here, then they will have to block like this. Then I win a bishop. I see. But I was not just even looking. Let's return back to the game. Which fork? Ah, how? Oh, he attacks this rook. Oh, I don't get. I beg, explain it to me. Sure. Okay, that stops the fork, but I lose the the pawn. That's what I didn't want to lose. Oh, how did I miss that? This was a really poor game. Okay, so as they allowed me escape that position, then yeah, the girl went to sleep. Wait, explain to me how that's not the best. If it takes like this, oh, okay, my king is in time. Um, I'm not sure I've ever played such a poor game. Let me put on some music, YouTube music. Okay, it's one of the sites. Yeah, right. Oh, it's music.youtube, not music, YouTube.music. Um, let's play files. Uh, bad. You have joined bad gang. You have joined secret court. All the fine girls. Oh, All the good guess. What sort of position are we playing? Why not? I thought it was past the bad guy. Which kind of nonsense is that? No, this is magic. Join gang. All the good girls are join gang. Yeah. Join gang. All the good boys are join gang. Yeah. Teenagers. What is secret? Bad gang. Bad gang. Bad gang. Bad gang. Well, what a good boy, what a change. Yeah, now you think guys are way older. About this, you're thinking you can reassure that. Not your eye is. You are feeling that. You use screen. Age of 24. I can't even know. It's more difficult. Everybody didn't see result. Child of the world, you have spoiled to the core. You have joined by gang. You have joined cyclical. All the girls are joined gang. All the good. Oh, no, no, no. It was a mistake. It was in blunder. Join gang. You are thinking of gang. Bad gang. Bad gang. Bad gang. Bad gang. Maybe I'm going way up. At this point, was a good boy, but we changed. Easy guy. Yeah. Really messed this position up. What am I doing? Ah, shit. Um, Baga, baga, ba. Oh shit. Oh shit. Okay, thank God. I still have a little. Okay. So I'm done a bishop and a pawn. Please don't return back to here. At least give me a chance to play. How did you miss that? How did you miss that? Yeah, they come around, I remember when money in my back account. Yeah, they love me. I'm a kilo coming. You know, he could have taken this pawn. Oh, okay, that was a better move. I will pass me my cup. I just want to have fun. I look at them as fun. Okay, if I can take this to a rook and rook end game, I should be able to draw it, but I don't have time. Rook and rook end game, that's the end goal. I have no big competition. Enemy na saba. La, 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 la. That's it. That's it. That's it. Okay. So now the goal to the goal is to try and tomorrow. I don't worry tomorrow. I don't gather my phone. If you hate to be my phone. If I wait for your turn, I'm drinking. I'm reading. I'm reading. On your. This meeting got no love, no love. No matter what you do. Okay, okay. The hell? Love before you go. You go hard before you go. I've been passing my car. I just want to have fun. I don't worry too much. I don't worry too much. I just got my phone. You know, I got the song. You didn't know my phone. Every day. Only reading. Okay, let's go. Let's go. Wait, this might be a mistake, and might cost me the game. But like, why not? CT, whiskey. Oh, Queen. Okay. Use enjoyment blind your eyes, baby. Use enjoyment kill you tonight. Okay, I'm running out of time. Ah, shit, I'm running out of time. How do I do this? How do you play this? Go. Go. Oh, yeah. Me to your life, your enjoyment for your life. This enjoyment give you tonight. Let me to your life. This enjoyment blind your eyes, baby. This enjoyment give you tonight. This enjoyment blind your eyes, baby. This enjoyment. Oh God, how am I going to do this? This is disgraceful. I'ma kill you, girl, tonight. See, you tell me I don't know. I cannot check and win this. I don't know how to do that. Go to the wrong square. I'm running out of time. I need to be quick. Hope that's not my data that finished. Bro, play now. Jesus Christ. Hey, nah, what you do? Um, I can't even pre-move. Me, I like Colorado. How do you set skill pre-move? Bro, I'm not playing. Please don't tell me that I've lost. Because my time is so low. If it's network that messed me up, then it'll be painful. Pass me along. Colorado, Colorado. Ah, shit, I've lost this game because of network. Game that I would have won with ease or drawn. Ah, it will not be better for Nigeria. Bro, suddenly my love is not there. Cover me like a cover. The fact that I think it's still loading like this is my own network that's bad. It's my own time that they are counting. Colorado, Colorado. Nintendo, Colorado, Colorado. Hey, fall in love. God, God, God. You go cut. Enough. Ooh. What am I doing? Eh. I'm gonna let's the end now. Ah, I won. That's crazy. The guy just threw it again. Oh god. New game. Press it do. Call me Charlie Poppy. Cause they're going to the more than multiply. Spotify. Whatever you say, yeah. More than you can defend. That's why I'm. What's going on? Mhm. Him. That's why I'm. More than multiply. The Spotify. Really deep here. Weekend. That's why I'm in love. I mean, he really can just sacrifice the same night. Ah, Jesus. How did I make such a mistake? Ah, shit. Oh, shit. Okay, no, it's not yet. Oh, shit, shit, shit. What am I doing? God said, go into the world and multiply. Hey, I'm just done a pawn. With accurate play, I should be able to salvage this game. I said with accurate play and then go on to Bonza. Ah, shit. Well, actually, I don't think that's really that bad of a move. Oh. This game is going to be locked for a long time. So, meaning that as long as I don't lose my knight, I'm okay. Ah, I've lost. Or it's my game to lose right now. Okay, no, I'm good. How do I want to play this position? 10,000 promises. Ah. Uka weka unka. Uka weka unka. Uka weka unka. Uka weka unka. That was a very close game. Uka weka unka. Uka weka unka. Uka weka unka. Ah. Unka weka unka. Money make I ball small. My day one. Stop listening. Today, tell me how market. The kissing. Oh, Sars, what's going on? Ugo, Ugo, welcome, Ugo. Let's see whether I can save it. Ugo, welcome, Ugo. Okay, let's bully the queen small. Ready, ready. It's all in my mind. I need plenty, hallelujah. Never party. Baby. Peace of mind. Peace of mind. What is up? Oh God. My money, my money plenty, hallelujah. Oh God, he has this move. Which one does he have? Okay, he has up there. Roses are red, violets are blue. Hey, making an aristocrat. Okay, okay. Yeah, yeah. Okay, now the guy will start to develop, and my advantage of him being a foolish player with hey, hey, aristocrat. As a unique girls, they are making the aristo. Hey, okay. Do I want to trade? I don't want to trade though. He's still 8 points of material ahead of me. Okay. Uh, uh, ban them. 19. Ooh, aristo. Aristocrat. Hey. Do I take that? That was a bad move. Oh, Jesus Christ. Oh, I forgot. I saw it. I saw it before I played the move. I was like, oh, he has that move. It's a bad move, but I saw it. And I was about to turn this game. New game. Start new. I saw it. I just used to fizz off. Like I'm listening to the music and just fizz off. Why is it not playing the next music? Continue watching. Bam Kodoba. Okay, let's win this game. Bam Kodoba. Like give me that Kodoba. I mean like they want that I don't want. I don't. It is very bad. You can wear my lover. You can never lie. You can wear. You can wear. You can never lie, they treat am well. You get that you hear the bad for where? Ipankun. Oh my god. Why am I playing nonsense? Godot. Give me back. It's just a bishop. It's just a bishop. No. Doggy dog, I stand defend the warrior. Ah, the monster, they bomb me. Aroma shida, aroma shida, aroma shida. Odumodu. Doggy. Oh my god. Soldier. Doggy, my banana. Okay, I've been playing the most diabolical chess since. Why am I clicking on rematch? What am I playing? Oh my god! What am I playing, Usas? Like, what kind of opening is that? Let me trade off the bishop. This is the opening that I do not know, or he just hung the last pawn. It's the opening I don't know. Why am I like this? Ah, I can just as well resign at this point. Baby, some money. You know, say you match my stays. You know I'm a G. Shawty, I'm a, let's keep it real. I know they for too much whiny. They for too much whiny. As it be, as it they enter. Oh yeah, she said, do, but I mean, love is in the air. Baby, breathe. Available. Available. Compatible. So for the compatible. Tell me bad man. Say, I did mellow. Baby, go down low. Nobody has to know. Baby, some money. You know, say, imagine my G. You know, I'm a G. Shorty, I'm always keep it real. I know they got too much whiny. They got too much whiny. As it they be, as a child they enter. Oh, yeah, make it color be. Oh, yeah, show yourself, do wasabi. Love is in the air. Baby, breathe. Manga, beautiful with personality. As a continuity where I know from my uh oh God. Baby, some money. You know, say you match my dreams. You know, I'm a dream. Sonny, I'm always keep it real. I'm always too much money. How did he miss that? Okay, I don't think he missed it. I just think it was a tempo move that I wanted to just get. Mm. Okay, he missed it. Okay, so I'm going to just push this guy and break out through this. I should tell you the end. Hey, hey. Ooh, ah, ooh, ooh. Wait, why did I make that bishop move? Or maybe it might be important in the future. Girl, it's your birthday. Go, 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 shawty. Okay. No, it's your birthday. I want to sack my bishop. Does it work? Fire, fire. Go, 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 shawty. You know, it's your... That does not do anything, right? Okay. First game, I was not like, Maya, Maya. Okay, now to it did not allow me to what was in my mind. Oh shit. I could have just pushed this pawn instead of scratching my pawn structure like that. No problem. I will survive. Why you? Please. Oh. Jollof rice. Top left. Top left. Okay, now I cannot do on passant again. So I can double push. But do I want to double push? That's another question. If I double push now, I won't be able to pick it up. If I won't double push, I'll push once. I'll take this and no, I won't take. What am I missing? Oh, that was what I was missing. Oh my god! How did I? There's no need to play again. If I take this pawn, if it takes this pawn and I take back, I can't allow him take it. I'm gonna meta shitty. Bad, badu, baddest. Hey, what sort of play am I playing right now? Why did I do that? Why am I making the moves I'm making? To me, no be. I said, a magazine. Why am I making the moves I'm making? The famous Pluto, in case you don't know. Charlie Poppy, Pluto Presido. Lambini, boy, bang, money, apa, money, repete, remi, and kawa, jai, sapere. Yeah, baby, colors, beanie, boys, we know they make too much noise. We come for it, we know the feeling, baby. In the river, but now you, I want it. Okay, I am down the pawn, but I can still make it work. I was just playing bad moves, I don't know why. See money, see money, see. Na be the pride of being Yoruba say suppose give us medal, give medal. Okay, the next is jump is Obiru. So you know they make too much noise when you. You are gonna, you are wanted. I'm almost mated. Wait, I'm mated. Ah. Okay, last game for today. What was that? Love you. Yeah. Promise. Yeah. I said you copy from here to I swear to Oh my god. Oh my god. Okay, it's not that bad. It's that bad. No, 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 no. That is why we are asking. Is it because I love you? Yeah. Oh, yeah, oh, yeah, yeah. Are we for real? 2 years. Coolest. What was that about to sound? Oh, how do you consistently do this? There's no reason why I'm still playing this game. Hey. Say no, say no, 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 I think this Oh shit, see mistake. See mistake. Better mistake. And he just allowed me go scot free. That was a nice one. That was a nice one. Well, I mean, Desperado, many, many, mommy goes, Balotelli, ladies taking me photo, paparazzi, Don Julio, Don Diami, Egumede Olao, Nipisaza Olao, Elementra Olao. I tried, but oh wait, it's not Adele. Lonely, yeah, yeah. I get it twisted. My body, my weakness, weakness. Something I go get nothing less. Che, che, che. What belongs to Odogu? That's mates. That's mates. Lonely, Is there any need of playing again? Minister of Enjoyment, Intercontinental, Monumental, we go live forever. Chop another banger, even man the most be mental, Smoky Zaza, man of the matter. Hey, you just be doing zigzag to come closer. Gangeli come along, you might dinner. You know me, I really wanna take you for dinner. You know me, I get the money flashing Navita. Come here, they call me Godzilla. You go there with the man for Palata. If you catch me, sure say you beat them. Say I give love you, you make it by my shadow. You know me not to do that, the corner of you, the only me. Mario. Here we go. Girl, you done make me there. Oh. Body make me go down low. Oh, you love, oh. African girl, come along, give my bima. You know me, I really wanna take you for dinner. You know me, I get the money, passion, navita. On my area, did they call me Godzilla? Oh, then you dance, pata pata. You dance, and make sure that you be down. If another nigga wanna be my vita, I go shut up, I'm like, cinnamon, it's like you. I like bad boys like you. Ooh, yeah, boys like you. Like bad boys like you. I give a bit of me, Iki baka begin maka ba ma shadow rema. You mean I do the dirty one for the corner. Not be too for any reason. Girl, I go there for you, baby, baby, Mr. Bombilla, you're back and making me my chance in a prayer. I'm not in a mo, I'm by your pillar. Yeah, this is really my rest and shida. Oh, yeah. You're back and making. So, I'm not going to win any game today. I'm by your pillar for you. This is really my rest and shida. Oh, yeah. African girl, come along, give my bima. You know me, I really wanna take you for dinner. You know me, I get the money, passion, vita. On my area, did they call me Godzilla? Catch and make sure that you beat am. Wanna be my senorita. I go chop am like senorita. Mm. Boys like you, I like bad boys like you. See, I give you, So how do I attack this position? So, look. Okay, so this has to be my last game. Body be dancing, small white, your way. Oh. Why did I do that? What am I playing? Okay, I need to get this knight into the game. This bishop is not doing anything in this square. Let's cause more confusion. Oh my god. I've never played this horrible in my life. Well, it will take this bit and pawn now. It didn't even take it. Oh, when shall I see Jesus and reign with him above, and shall hear the trumpet sound in that morning, and from the flowing fountain, prepares for us a blessed, and shall hear the trumpet sound in the morning. At this point, is to sack. But I can't be sacking when I'm so low in material. And shall hear the trumpet sounding morning. Oh, shout glory, for I shall march above the stars when I hear the trumpet sounding morning. Okay. Oh, when shall I see Jesus and reign with him above? I shall hear the trumpet sound in the. Oh, that's meat. Oh, it's not meat. In that morning, and from the glowing fountain, prayers for us a blessed. I shall hear the trumpet sound in the morning. Oh, shout glory, for I shall march above the sky when I hear the trumpet sound. Meat. Oh, today was a horrible day of chess. Let's see.